In this section, we're going to talk about the different qualities and the different features of statistical study designs. So the first thing we want to look at are some different types of variables. One type of variable is called the explanatory variable. This is just a new word or another word for the x variable. It may also be called the predictor, the input, or the independent variable. So those are all words for the same thing: explanatory, x, predictor, input, and independent. Treatments are the different values of the explanatory variable. So anytime they talk about applying a treatment, that is an x variable, or a predictor. The response variable is like your y variable. It is what is predicted, the output, or the dependent variable. Something is called a confounding variable. It can also be called a lurking variable. If it's a variable other than the explanatory variable that may explain why the outcome occurs. So we have to be very careful about these confounding or lurking variables. So here's an example. It says you want to know if there is a relationship between the amount of time a student spent studying for an exam and the student's grade on that exam. First of all, what are the explanatory and the response variables? So again, your explanatory is like your x value or your input. So that is going to be the time studying. And the response is like your y or your output, and that will be your grade on the exam. Now, what could be some possible confounding variables in this situation? Well, it asks for one, but there could be many. So basically what this is asking is, what are other things that right now are left unaccounted for that could possibly cause a certain grade on an exam that has nothing to do with the amount of time someone studies? So things that come to mind to me might be the amount of sleep someone got the night before. So someone could have studied just as much as someone else, but had a horrible night's sleep, and that could certainly affect the outcome variable, but have nothing to do at all with the study time. What about breakfast quality? Right? That could affect your outcome on an exam, but not have anything to do with the amount of studying you did. And there are all kinds of these confounding variables. Maybe a job that somehow got in the way of this. Your kids. Maybe you are in extracurricular activities. And I'm sure there are hundreds and hundreds of more that we could come up with. All these things could affect your outcome on that test, but not really have anything to do with the amount of time studying. We will talk about how to keep those confounding variables to a minimum here in a minute. The treatment group is your group that receives the treatment, and then the control group is the group that does not receive the treatment. Okay, so let's talk about two different types of studies. The first type is called an observational study. These are when subjects are placed into different groups by choice. No attempt is made to control any aspect of the individuals in the sample. So you just kind of let people do whatever they want to do. In this case, there's no assurance that the groups are the same in all ways except for the treatment variable. Because people just get to self-select, so you haven't taken control of any aspect of what's going on. When this happens, there's a strong likelihood that a confounding variable exists. These are often used when it's impossible, difficult, or maybe even unethical to control factors in your sample. So an example would be a study on the relationship between smoking and lung cancer. In this case, it would probably be unethical to force someone into a smoking group, right? Against their will. you probably cannot make someone smoke for a certain amount of time. So the best you could do in this case would be to do an observational study where you take subjects who have made these choices on their own and you study them. Unfortunately, that just means that there are probably confounding variables. People who maybe choose to smoke may also choose to do other things, and maybe it's one of those other things that contributes to the lung cancer. And so you just have to realize that anytime you're doing an observational study, there could be these lurking variables. What this means is that we can never draw cause and effect conclusions from observational studies because of these potential confounding variables. A single observational study can show only that there is a correlation between the treatment and the outcome variables. So you could certainly say there is a correlation between smoking and lung cancer, but you maybe cannot go as far as to say it causes it unless you have actually done more controlled things. So what's really important here is to make the note that correlation does not equal causation. Just because two variables are correlated, even if they're correlated very strongly, there's a very strong link between them, you cannot necessarily say then that one causes the other. That leads us to a controlled experiment. A controlled experiment is where researchers control one or more aspects of the individuals in the sample. They may do this by assigning the subjects to the control or treatment group, so do some assigning. This ensures that the groups are as nearly alike in every relevant way except for the treatment under investigation. Well-designed and executed controlled experiments are the only way to determine causality. And there are some features in order to be considered what we call well-designed. To be well-designed, you would like to have random assignment into the groups, a placebo, blinding or double blinding, and a large sample size. Now, it's not always possible to get all of these features, but the more of these that you can get, the better of a controlled experiment that you can perform. Okay, so let's look at what are a couple of these definitions. So random assignment means whenever you assign the control and the treatment group, and it's totally left to chance. No human determines the assignment. You either flip a coin or use a computer program or a calculator in some way, because humans are always biased in some way. If I started picking groups, I would pick certain people to be in certain groups, maybe without even realizing it. So you want to leave it up to complete chance. Blinding is whenever you prevent either the subjects or the researchers from knowing who is in the control or treatment groups. So when you talk about double blinding, that's when both the subjects, I guess it should say, when neither, that'll make it actually make sense here, when neither the subjects nor the researchers know who is in the control group or the treatment group. Why would you want to do this? Well, because this will prevent bias from the group members themselves who may act differently if they know that they are being treated in a certain way. And it will also prevent bias from the researchers who may treat or judge the subjects differently based on which group they're in. So think about it. If you knew that you were receiving the real treatment for some disease, let's say, if you knew you were receiving the real treatment, you may then go do other things to help your chances, right? I know I'm getting this treatment, so I'm going to start eating better and I'm going to start exercising and I'm going to start doing all these things because I want everything going for me. Whereas if I know that I'm getting the placebo, if I know that I'm not really getting the treatment, then maybe I just kind of go on a self-destructive path. And then it could be any of those other things that actually makes the outcome happen. And the researchers, if they know who is getting, the treatment and who's not, They may just look harder for those people who they know are getting the treatment, and any tiny little improvement, even if it's so minute, they may mark that down, and they may sort of forget about the other group. They may not notice those same features in that other group just because they are expecting it. So it's better, if possible, for nobody who's involved to know who's actually getting the treatment and who's not, so that their judgment isn't clouded.